Abundant Grace International School, we are located right in Obuasi, precisely BDM. The school has a number of facilities that aid in learning. We have qualified and trained teachers who are ready and willing to assist the children. The school has many facilities such as the ICT laboratory. We also have a science laboratory. We also have a library. The school has a number of buses which convey the children from their various destinations to the school premises. We have the football team, we have the drama group, we have a lot, and the school is based on the Christian principles. For more inquiries, you can call this number 0541 310 901 0541 670772. Abundant Grace, in God we trust.
Hello, good morning, viewers. You're welcome back to your science session. Our topic for today is acids and bases. Our topic for today is acid and bases, and I want you to pay attention to what we are going to learn today, because this topic is a little bit complicated, and I want you to pay extra attention. Now, before we start, let us go through the learning objectives. Before we start, let us go to the learning objectives. Now, they can ask you questions, and the question is based on the learning objectives. So let us go through the objectives first. So after learning this unit, you should be able to explain the term acid and base. Explain the term acid and base. 2, distinguish between an acid and a base. Distinguish is the same as differentiate between an acid and a base. And 3, classify substances such as acid or bases. 4, predict the products formed when an acid reacts with a base. Predict the products formed when an acid reacts with a base. So we are going to start the lesson. So I want you to pay attention. Now, we have the definition of an acid on your screen. Now, an acid is a compound that turns blue litmus paper red. An acid is a compound that turns blue litmus paper red. And I want you to notice something here. An acid is a substance that turns blue litmus paper red. Now we have a keyword, blue litmus paper. Blue litmus paper red. So if a substance turns a blue litmus paper red, it means that that substance is an acidic. Now, this litmus paper was used in the olden days. This litmus paper, we have blue litmus paper and we have red litmus paper. We have 2 of them. So this litmus paper was used in the olden days to test for acid and base. And it is used in present day. So we have this litmus paper. We have blue and red litmus paper. Now, this one is used to test for acid. This one is used to test for acid. So take note of that. So if they dip this blue litmus paper inside any solution, we don't know whether it is acidic or a base. So if the solution is acidic, as soon as they dip in this blue litmus paper, it will change from blue to red. This litmus paper will change from blue to red, which shows that the solution is what? Acidic. Now, the same, if they dip in the red litmus paper in a certain solution, if the litmus paper turns blue, it means that that solution 2 is what? A base. It means that that solution 2 is a base. So they normally use this litmus paper to test for acid and base. But if you dip blue litmus paper in a certain solution, and the litmus paper remains the same, if it is blue, it means that that solution is a basic, it's a base. And if you dip red litmus paper in a certain solution, and that litmus paper remains the same color, it means that that solution is an acidic. So take note of that. So an acid is a compound that turns blue litmus paper red. Or another definition of an acid is a substance that produces hydrogen ion when it is dissolved in water. Let me write it on the board for you. Now look on the board. Now we have an acid is a substance that produces hydrogen ions when dissolved in water. This is another definition of what? An acid. And we can also define an acid as what? An acid is what? A proton donor. It donates hydrogen ions. So another definition for acid is so if you can take any of the definition of an acid, it is accepted. So an acid is a proton donor. This is another definition of what? An acid. So this is the first one. An acid is a compound that turns blue litmus paper red. Another definition of an acid is on the board. An acid is a compound that produces hydrogen ion when dissolved in water. Or an acid is a proton donor. You can take one of the definitions of an acid. I have given you 3 definitions of what? An acid. Now let's go to examples of an acid. Let's go to examples of an acid. Now, we have some examples of an acid. We always come across acid and base in our everyday lives. So we have example, we have ACl. We have ACl over there. Or you can see some of the example on your screen. The first one, we have sulfuric acid. Sulfuric acid. Sulfuric acid. We have H2SO4. You can see it. This is the chemical formula for sulfuric acid. Now, we have the words over there, sulfuric acid, that H2SO4 is the chemical formula. So take note of that. Take note of that. So H2SO4, we have hydrogen, sulfur, and oxygen. They come together to form sulfuric acid. The next one is nitric acid. Nitric acid. We have the chemical formula is NHNO3. HNO3 is the chemical formula for nitric acid. So we have HNO3. This is the nitrate. So the addition of hydrogen makes it an acidic. This is the sulfates. So addition of the hydrogen make it an acidic. That is why another definition of acid is what? An acid is a substance that produces hydrogen ions when dissolved in water. That is a substance that produces hydrogen ion that when dissolved in water. So we have here hydrogen here, we have another hydrogen here. So addition of this hydrogen makes it an acidic. So another example of acid is HCl, hydrochloric acid. Hydrochloric acid is here. So the addition of this one, when it combines with what, the chlorine, you get hydrochloric acid. Now, I want to talk about this acid. Now, the hydrochloric acid can be organic and inorganic. This acid is found in the stomach of human being. Take note of that. So this one can be prepared in the science laboratory and it can occur in nature. It can occur in nature. So the acid that is found in the stomach of human being is hydrochloric acid. Take note of them. So they can ask you, this one can be found, can be in the objective tests. So take note of that. So this one can be organic and inorganic. Take note of that. So this is the chemical formula for hydrochloric acid. And we have another example of acid. We have carbonic acid also there. We have H2CO3. Carbonic acid is also there. All these are examples of acid. All these are examples of acid, so it is not difficult. So if you are told to state 3 examples of acidic substance, I hope you can mention some. All these are inorganic acid. Only these can be organic and inorganic. Now, let's go to types of acid. We have 2 types of acid. We have organic and inorganic. We have 2 types of acid. Now, there are 2 main types of acid based on their sources. Take note of that. Based on their sources. We have organic and inorganic acid. Now, let us calm down. I want you to understand the term organic and inorganic. The term organic acid. Now, organic acid, this acid is produced in nature. This acid is produced in nature. Now, we can get organic acid from the food we eat. Now, for example, the end product of protein is amino acid. This is a typical example of what? Organic acid. This acid occurs in nature. This acid is not prepared in science laboratory. You can get it from plants and animals. I want you to take note of that. Organic acid occurs in nature. It's a natural occurring acid. Now, when you eat food that contains protein, you can get amino acid from the food. So now, amino acid is a typical example of what? Organic acid. Now let us define organic acid. These are acids which occur naturally. I told you. This acid occurs in nature. It occurs in nature. We can get some in plant and animal sources. Now we have the table on your screen. We have organic acid and we have its source. The first one is what? Lactic acid. The first one is lactic acid. Lactic acid. Lactic acid. Now, its source is milk. Now, if you can see a woman who has given birth, and that woman, if the woman is what? Feeding her baby, because lactation, the process is known as what? Lactation. If the woman is giving breast milk to the baby, is what? Lactation. So we have to understand this. So the term, its source is what? Milk. So lactation. So, and we also have what? Lactogen. We also have lactogen over there. If you go there, you can also get some to buy at the market. Okay. So its source is what? Milk. It contains a lot of what? Milk. So the source is what? Milk. Now, let us go to the next example. The next organic acid is citric acid. Citric acid can be obtained from unripe lemon and grapefruits. This is its source. Okay, citric acid. The next one is palmitic acid. As then look at its name. We can get this from palm oil. We can also get this from palm oil. I told you earlier on. The next one is amino acid. The next one is amino acid. Amino acid can be obtained from protein. Amino acid can be obtained from protein. The next example of acid is acetic acid. Acetic acid can also be obtained from vinegar. Vinegar has been used since 1900s. We normally use vinegar in our kitchen to preserve food. So I hope you know vinegar. Now, another one is methanoic acid. Methanoic acid, we can get it from red ants. We can get it from what? Red ant. And the next one is salicylic acid, aspirin. Aspirin too is what? A kind of medicine, a kind of what? Painkiller. Aspirin is a kind of what? Painkiller. And the next one is tartaric acid. We can also get tartaric acid from grapes. And the next example of organic acid is ascorbic acid. Ascorbic acid, we can also get it from what? Rancid butter. Or another name for ascorbic acid is butanoic acid. It is obtained from butter. And we have bee stings from what? Bees. All these are examples of organic acid. I told you that organic acid are produced in nature. They are produced in nature. We can get it from animal source and plant source. They are produced in nature. We can get it from animal source and plant source. Now, I hope you can define, if you are told to define organic acid, you can define it. Organic acid occur in nature, or they are naturally occurring acid. Take note of that. It can be found in plants and animals. And they are weak acid. All organic acid are weak acid and less harmful to man. All organic acid are weak acid and less harmful to man. Take note of that. They are less harmful to man. Now, the next one is the property of an acid. Now, what I'm going to say is very important. If you are going to answer a question based on acid, you have to know the properties. If you want to answer a question based on acid and base, you have to know the properties. If you don't know the properties, you cannot answer any question concerning acid and base. So I'm going to take them one after the other. The first one, acid have a sour taste. Acid have a sour taste. It is neither bitter nor sweet. It is neither bitter nor sweet. Acid have a sour taste. It is neither bitter nor sweet. Take note of that. It is neither bitter nor sweet. Now, the next property is strong or concentrated acid are corrosive. If something is corrosive, it means that it can burn the skin. If something is corrosive, it means that it can burn the skin. It can burn the tissue of the skin. So take note. So strong or concentrated acid are corrosive. Strong or concentrated acid are corrosive. If something is corrosive, it means that it can burn the skin. It can burn the skin. It can burn the skin. So take note of it. The next one is they turn wet blue litmus paper red. This one is based on what? The definition. An acid is a compound that turns blue litmus paper red. So in the olden days, they were using what? This litmus paper to test for acid and base. So if the substance is acidic, the moment you dip in the blue litmus paper, it will turn from blue to red. So that you will know that the solution is what? An acidic. So they turn wet blue litmus paper red. This property is used to test for acid. Take note of that. Now, the next one, they react with metal to produce hydrogen gas. Now, in other book, they react with metal to produce salt and hydrogen gas. They react with metal to produce salt and hydrogen gas. So here, I want you to pay attention. They normally ask questions on the fourth property. I want you to pay attention. It is very important. Now, let us go to board. Let us go to the board and do some chemical equation there. We have zinc metal. Now, here, this is the metal. And we have the acid here. Now look at the property. Acid reacts with metal to produce salt and hydrogen gas. So here we have metal plus acid. The product, we get salt plus hydrogen gas. So I want you to understand this before we go to the chemical reaction. Now, metal plus acid maps to salt. The first product is salt, and the second product is hydrogen gas. I want you to understand this before we go to the chemical reaction. Now, before we start on the chemical reaction, let us look at the ionic formation. In compound, cation and anion come together to form compound. So here is a typical example of what a compound. This is the metal. So here, this is cation. Here too, we have the cation here, and we have the anion. So the chlorine is negative, and the hydrogen here is acting as what? A metal. So it is what? Positive. And we have another metal here. Okay, so this one is not difficult. Take your time. Compound, cations always combine with what? Anion to form what? A compound. So here, we have this, we'll take this. Assuming this is what? This is a man and this is the woman. So the man is going to marry this woman. Okay, so the zinc is man and the chlorine is what? A woman. So the zinc is going to get married to the chlorine here. So you write the name of the man first. Second one, then you write what? The woman. So the first product is what? The salt. So this is the salt. This is the salt. So here it has left with the hydrogen atom. So you just this thing, you write H. But in a chemical reaction, the hydrogen appears what? Diatomic molecule. It appears what? Diatomic molecule. I want you to pay attention. You cannot write just H like this. If you write H like this, you are wrong. In chemical reaction, the hydrogen appears as a diatomic molecule. It contains two atoms. So you just add 2 to this. So here we have 2 atoms of hydrogen here. But here we have only 1 atom of hydrogen. I want you to pay attention. And if you want to balance this chemical equation, you add 2 here. You write 2 in front of this compound so that we can get 2 atoms of hydrogen here. But here, this 2 is multiplying what is in the compound. It's like something like this. 2 into bracket HCl, like this. So here, you get 2 atoms of hydrogen, you get 2 atoms of chlorine. So these 2 is multiplying the hydrogen and at the same time multiplying the chlorine. So we have 2 atoms of hydrogen. Here we have 2 atoms of hydrogen. Here, 2 times the chlorine, you get what? 2 atoms of what? Chlorine. So we have to add 2 to this chlorine here. You cannot write 2 in front of the zinc because here we have only 1 atom of zinc here. So you write 2 in front of this chlorine so that the equation can be balanced. So this is the product. So acid reacts with metal to produce salt and hydrogen gas. Let me go back and explain this again. Acid reacts with metal to produce salt and hydrogen gas. So here we have metal. The metal is what? Zinc. Zinc plus HCl. HCl. I'm taking it again. Now, the ionic formation of the various what? Elements and compound. Here is positive. Here too we have H, positive, and we have Cl, negative. This is the ionic formation. So you have to know that when you are balancing what any chemical equation, always the positive takes what? The negative to form a new product. So this will take this. Okay, but you cannot write ClZn. This one is wrong. This one is not accepted because the name of the metal is written first before the gas. This is a gas and this is a metal. So when you are writing down what? A compound, if you are told to write a chemical formula for the following compound, you have to make sure that you write the metal first before the gas. Now, this is the gas and this is the metal. So you write the name of the metal first. This is a chemical symbol for zinc. This is a chemical symbol for zinc. After that, you write the gas. Capital C, small l. If you write zinc like this, Z and capital N, this one too is not accepted. This one too is wrong. This one too is not accepted. So you just write small capital Z, small n. This is a chemical symbol for zinc. And the chlorine to the same thing. Capital C, small l. It's not capital C, capital L. This one too is not accepted. So I want you to take note of them. It is very important. I want you to take note of them. So the next one, this is the salt. This is the salt. This is the salt. Okay. So acid, metal reacts with acid to produce salt and water. So here, this is the metal. This is the acid. So this combine to form salt and hydrogen gas. So now we are looking for our hydrogen gas. And I told you that in a chemical reaction, hydrogen, oxygen, and iodine, they all appear as what? Diatomic molecule. So you just add 2 to this. Add 2 to this. So here we have 2 atoms of hydrogen. We have 2 atoms of hydrogen. Here we have only 1 atom of hydrogen. So for you to balance the hydrogen, you put 2 in front of this compound. You put 2 in front of this compound. So here, this 2 is multiplying hydrogen and what? Chlorine. It means that we have 2 atoms of chlorine here. Here too we have 2 atoms of, we have 1 atom of chlorine. So you write your 2 here so that we can get 2 atoms of chlorine. And here too we can get 2 atoms of chlorine. You cannot write it in front of the zinc. If you write it in front of the zinc, you are wrong because here we have only 1 atom of zinc atom here. We have only 1 atom of zinc. We have only 1 atom of zinc. So if you write a 2 in front of this, you are wrong. So this 2 is multiplying this and this. So for you to balance the chlorine 2, you write 2 here. So that you can get 2 atoms of chlorine, 2 atoms of hydrogen. So if you count the number of atoms, you can get 2 atoms here, 2 atoms here, 2 atoms here, 2 atoms here, and 1 atom of zinc. This one is correct. This one is correct. So take note of that. Let us take another metal. Sodium reacts with hydrochloric acid. Sodium they also produce salt and hydrogen gas. Now, look at this one too. Here, we have the metal here. We have acid. We have metal here, we have acid. Our product is salt and hydrogen gas. So this one is the basis. So we have to know the basis before you do the chemical equation. Now here, this one too is positive and negative here. So this will take this. So you write the name of the metal first, something like this. So the metal will come first, sodium. Then after that, you write your Cl. The next one is H2. H2, we have 2 atoms of hydrogen here. So if you want to balance the hydrogen, you add 2 in front of this compound. And because of these two, we are having 2 atoms of chlorine here. Then you add 2 atoms of, you add 2 to the chlorine so that you can get the 2 atoms at the other side. So here, if you count the number of atoms, here we have 1 sodium atom here. Here too, we have 1 sodium atom. 2 times this, we get 2 atoms of chlorine. Here we have 2, and we have 2 atoms of hydrogen. We have another 2 here. So take note of that. This one is not difficult. Just take your time and do it. It is not difficult. It is not difficult at all. Now, the next example is magnesium. Let's take magnesium metal. Now you can see this is the metal and this is the compound. You can see it. Magnesium reacts with hydrochloric acid to produce salt and water. Now let us balance this chemical equation. Now this is positive, and this is negative. So this will take this. We have MgCl. MgCl. We have only this here, H2. This one must be diatomic molecule. You just write 2 in front of this compound. Because of these 2, it is affecting this chlorine. You add this one. You add 2 to this, making this one is very simple. So this is the metal. This is the metal acid. Magnesium chloride is a salt. And we have the hydrogen gas. We have the hydrogen gas. So I want you to take note of them. This one is not difficult. So if you are told to balance any chemical equation concerning what? The atom, we have to know. This one is very simple. And let's go to the practical. We have some diagram over there. This one, if you made this question, a question like this, they will draw the test tube for you. They will draw the test tube for you like this. They will draw it for you like this, and here you can see they will put in something here. So on your screen, you can see the diagram, but in exams, they will not give you that diagram. They will just draw something like this. So I want you to pay attention. We have bubbles. Something like this. In here, you can be told to label the parts. This is how, and here too we have so they can draw it for you like this, and you can be told to what? To label the parts. So you have to know that the metal is having greater density. So if you put the metal in the test tube, it will sink to the bottom of the test tube. So this one is the metal. This is the metal. We have here, which is the ACl. This one, if you write this one, it is accepted. We have bubbles, the II, bubbles. The bubbles, this material, this you have to know that this one is the hydrogen gas. This one is the hydrogen gas, and here is the test tube. Test tube. So they can draw it for you to label the part, and after that, they will ask you a question under it. And the next question they will ask you is what? To balance the chemical equation. Balance the chemical equation. So here, the metal can be what? Zinc or any other metal. So if you write a metal, you can just do like a zinc or any other metal. Or they can give it to you. They can label this for your zinc. So after that, you have to sit down and label and balance what? The chemical equation. So if zinc is given, you just write Zn plus Cl. If you are told to write a balanced chemical equation for the reaction, because if this is the acid, as soon as they put the metal, zinc metal, in this test tube containing the acid, chemical reaction will take place. So how can you write down the chemical reaction as a chemist? So you have to know. So as soon as you label the part, they will ask you to write down the chemical equation for the reaction. So you have to know. So to write down the chemical reaction for the reaction, you write the name of the metal first. After that, you bring this operation sign. Then you go to the acid. Then you go to the acid, ACl. ACl, this is the third one, ACl. So after that, then you go in for the product. But before you can balance this chemical equation, you have to know that acid reacts with metal to produce salt and hydrogen gas. If you don't know, it means that you cannot balance this equation. But if you know that acid reacts with metal to produce salt and hydrogen gas, then you can balance this equation. So you know that the first product will be salts, and the second product will be what? Hydrogen gas. So let us go back and balance this chemical equation. Now this will take this. So we have zinc chloride plus A2. So after that, you write 2 in front of this, you write 2 here, so that the equation can be balanced. So if you want to know that an equation is balanced, you have to count the number of atoms at the left-hand side. After that, you count the number of atoms at the right-hand side. That will tell you that the equation is balanced. Now here, we have 1 atom of zinc. We have 1 atom of zinc. If you go to the other side, we have another 1 atom of zinc. So it means that zinc is balanced. 1 here, 1 here. So we are done with the zinc. Now let's go to hydrogen. Here we have 2 atoms of hydrogen. We have 2 atoms of hydrogen. Here we have 2 here. We have 2 here. 2 times this will give you 2 atoms of hydrogen. So the hydrogen is balanced. And here too we have chlorine. This 2 is multiplied this chlorine. So 2 atoms of chlorine, 2 is here. So we have another 2 atoms of chlorine. Now let me give you another example, which is arrow. Now you can write zinc plus HCl Now, look at the second equation. Look at the second equation. We have zinc here. We have hydrochloric acid here. We have zinc chloride and hydrogen atom. We all know that acid reacts with metal to produce salt and hydrogen gas. So you may think that the moment you get your hydrogen gas here, you are correct. You can get it wrong. I want you to pay attention. You can get it wrong. So the moment you add 2 to this, it means that we have to count the number of atoms at the part, the left-hand side. Now here we have only 1 atom of hydrogen here. So here too we have 2 atoms of hydrogen. So this and this are not balanced. Take note, are not balanced. So take note of them. So this one is not accepted. This one is wrong. So this equation is wrong. And the first one is the correct one. So take note of that. So the moment you finish, you start counting the number of atoms at the left-hand side and the number of atoms at the right-hand side. So here we have 1. Here we have 1. It is accepted. 1 here, 1 here. It is balanced. But here we have 2 here. We have 1 here. So which means this one and this one are not balanced. So this one is wrong. So it makes the whole equation wrong. So you have to take your time and go through. You have to take your time and go through. So now, look at the first equation. Zinc plus A2L. Now let me clean the 2. Now, the first thing you have to know is that all gases, most of the gases appear in a chemical reaction as well, diatomic molecule. Diatomic molecule. Now, let me give you a typical example before I go back to this. Now, we have carbon dioxide, C plus O. This one, we have O2 here. We have O2. So if you combine this one too is what? A typical example of a diatomic molecule. So we have CO2. This one is a typical example of diatomic molecule. Another example of diatomic molecule is what? N2, AI2. All these are example of what? Diatomic molecule. So when they combine, they form this one. So I want you to take note, and the hydrogen is part of them. Hydrogen is part of the diatomic molecule. So in a chemical reaction, you cannot write just the H like this. If you write this one, it is not accepted because hydrogen appears in what? In a chemical reaction as diatomic molecule. So you add your 2 to this. So the 2 to this hydrogen change everything. The 2 to this hydrogen changes everything. So we have 2 atoms of hydrogen here. Here we have 1. I want you to pay attention. Here we have 1. So for you to what? Balance this what? Equation. You cannot write a 2 here. We don't have any compound that looks like H2Cl. This one too is wrong. Chemical formula for hydrochloric acid is HCl. Like the chemical formula for water. We don't have this. Chemical formula for water, if you go to China, it is H2O. If you go to US, it is H2O. We don't have chemical formula for water being H2O2. This one is not water. This one is used at the hospital. This one is hydrogen peroxide. This one is used to dress what? Wound. This one is used to dress wound. This one is hydrogen peroxide. This one is not water. This one is not water. So water, chemical formula for water is H2O. It is accepted everywhere. So you cannot change the chemical formula for the compound. You cannot change the chemical formula for any compound. So if it is H2O, it is H2O. It is accepted everywhere. This one is hydrogen peroxide. This one is used at the hospital. This one is meant for special purpose. So you have to take note of that. So to balance what this compound, to balance the hydrogen, you cannot write the 2 here. If you write 2 here, you are wrong. It is not accepted anyway because this is the chemical formula. But if you write 2 in front of this, it is accepted. If you write 2 in front of the compound, it is accepted. It is accepted. So here we have 2 atoms of hydrogen. And this one too is multiplying the chlorine. In mathematics, you do expansion. We have to understand this one. Expansion, 2 into bracket A, B. Like this. It's the same thing here. 2 into bracket AB, you get 2AB. Does not make any difference. I want you to understand. That is why I'm giving you more examples. 2 into bracket AB is 2AB. We'll give you 2AB. We'll give you 2AB. So this one is the same thing. So 2 is multiplying the H and it is multiplying the chlorine. So here, if we have 2 atoms of chlorine here, 2 atoms of hydrogen here, we have to get to our 2 atoms of what? Chlorine. So you cannot write 2 in front of this because here we have only 1 atom of zinc. Here we have only 1 atom of zinc. Here we have only 1 atom of zinc. So you write the 2 here so that you can balance the chlorine. So that you can balance the chlorine. So here the equation is balanced. So if you count, here we have 1 atom of chlorine, a zinc here. Here we have 2 atoms of hydrogen. 2 times this, we get 2H. Now here we have 2 times this, we get the same thing here. So we have 2 atoms of hydrogen, we have 2 atoms of chlorine, we have 1 atom of zinc. Here we also have 1 atom of zinc. We also have 1 atom of zinc. I want you to pay attention. This one is not difficult. So anytime an acid reacts with metal, you get salt and hydrogen gas. And I want to take my time and explain this one. So I'm going to end here. We shall meet on Wednesday so that I will take you to another property. So I'm going to end here. Thank you for watching. See you on Wednesday.
Abundant Grace International School, we are located right in Obuasi, precisely BDM. The school has a number of facilities that aid in learning. We have qualified and trained teachers who are ready and willing to assist the children. The school has many facilities such as the ICT laboratory. We also have a science laboratory. We also have a library. The school has a number of buses which convey the children from their various destinations to the school premises. We have the football team, we have the drama group, we have a lot, and the school is based on the Christian principles. For more inquiries, you can call this number 0541 310 901 0541 670772. Abundant Grace, in God we trust.